Hey guys, welcome to my great bonding project. Today we're going to be talking about covalent and ionic compounds. So covalent compounds share valence electrons and are nonmetals. Ionic compounds transfer valence electrons and are nonmetals and metals. So, for example, KOH would be ionic and IF would be covalent. So we know KOH is ionic because K is a metal, O is a nonmetal, and H is a nonmetal too. So nonmetals and metals create ionic bonds. So now we're going to look at their electronegativity, which I actually already wrote down here. So K and O have an electronegativity of 2.7 because potassium, or K, has an electronegativity of 0.8 by itself, and oxygen has electronegativity of 3.5 by itself. So we just subtract 0.8 from 3.5 and we get 2.7. And oxygen and hydrogen have a combined electronegativity of 1.4 because oxygen has 3.5 and electronegativity and hydrogen has 2.1 electronegativity. So if we look at our electronegativity chart, you can see that from 2 and above all the way to 4 is actually ionic. And let me just write that real fast. There we go. We have it all written out. So from 0.4 to 2 is polar covalent, and from 2 to 4 is ionic. And you can see that K and O is 2.7, so it is ionic. Now let's draw a model for our ionic compound. So we're going to draw K here and O over here, and O has 6 valence electrons, sorry. And hydrogen's going to be connected to 1, so now it is going to be connected, so it has 7 valence electrons. So now we need one more. So potassium is actually going to give oxygen its electron because oxygen has such a high electronegativity. That way, oxygen and potassium are both happy because now they have a full valence shell. So now let's draw our model for our ionic compound. So let's draw K in brackets. And K is actually going to have a positive charge now because it got rid of one of its electrons. And electrons are negative, so of course it's going to have a positive charge. And now we're going to draw O and H in the same brackets because oxygen and hydrogen are connected with an electron. So we're going to draw them together. So now they both have a negative charge because they gained one electron from potassium. So now let's find our covalent compound. So I am using IF7. So I has an electronegativity of 2.5 and F has an electronegativity of 4. So if we subtract 2.5 from 4, it will give us 1.5, which is pretty good and is in the polar covalent area. So that gives us a covalent compound. And let's just draw it down here too. 1.5. That is its electronegativity, which again is polar covalent. So now let's draw a Lewis structure for our covalent compound. So since it's IF7, it is going to have 7 bonds. So let's draw I. 1, 2, 3, 4, 5, 6. Well, now I missed one, so 7. There we go. Now just draw the F's around the sides. Oh. And there we go. So this compound actually breaks the octet rule because it has 7 bonds, and each bond has 2 electrons. So there would actually be 14 electrons in here, which is well over 8, right? So the octet rule just means that the connecting elements will equal up to 8 valence electrons shared together. Now for our 3D model. Wait, where'd it go? Let me fix that. There we go. Alright, so for our 3D model, the central atom is actually going to be I, and the atom on the outside is F. And we already know that from our Lewis structure. So again, it has 7 F's on the outside, and it is connected to I. So let's draw it as a wedge-line model. Wait, where'd that one go? Can't believe it, that one got away too. Let me fix that. Alright, there we go. There's our wedge-line model. So for our wedge-line model, it looks kind of funny at first, but I'm gonna highlight this. So these would be just flat down on top of the table, right? Just if you put a pencil down on a table. So the dashes would be as if a pencil went through the table and underneath the table. So it would be below the table. And for the wedges, it would actually be coming up at you. So let me just highlight them. So wedges are kind of like exclamation points. So again, it would be just kind of like a pencil coming at you, or yeah, just kind of standing off the table, right? Pretty easy. So now let's compare it back to the 3D model. You can kind of see it. You can see how it goes back, right? And we added the lines of it going back and coming at us, right? Yeah, you can see it. So now it has a name, of course. Every science thing has a name, and it's actually kind of a weird name. It is called a there we go. So pentagonal bipyramid, that's what we would call it. So it's kind of weird because it's not a pentagon or a pyramid, but that's okay. Science terms are just weird in general, and we can forgive them for that because there's so many terms, right? But that is basically it. That was my great bonding project. So I hope you guys enjoyed my great bonding project, and I would love to hear some feedback from you guys. And yeah, I hope you guys enjoy the rest of the bonding projects. Peace out. Oh, wait, hold on, give me a sec. What is that? That on the bottom, yeah, that. Let's check it out. IF, you know I have to redraw you. You know what? We're not gonna let this stand. Let's get rid of you. Because you're just out here having a nice dinner while I'm working. That's right. No dinner. You don't know you either. That's right. You're all gone. Final ending.